Hello everyone, you're welcome to my channel. My name is Tosin George. I'm a data scientist living in Lagos, Nigeria. I create tutorial videos around topics in data science, basically just documenting my journey in this space. Today, we're going to try our hands on a hackathon on the Zindi platform. If you do not know Zindi, Zindi is one of the largest professional platforms for data scientists in Africa. You can see the Zindi platform right here on my screen. Please note that this is not an ad. This is not an advert for Zindi. I basically just tried my hand on a hackathon and I want to teach you how I did it. So don't think this is an ad. All right, so back to the Zindi platform, one of the largest platforms for data scientists in Africa. I usually, not that I usually use D&D for competitions, but I like the type of competitions and hackathons that they have on there. It's really focused on solving problems in Africa. So I really like the platform. I really just also got started on, participating in hackathons, and I do hope to participate in more hackathons in the future. So let me just take you through, what the Zindi platform is like, and then we'll go straight into how I did the first hackathon so that you can also try it as well. So now on the compete, if you sign up on the Zindi platform, this is what you see, or in my case, this is what I have. So on the compete tab, you can see the competitions that are there. You can compete for money, you can compete for knowledge, you can compete for points on the platform. So these are the different challenges you have, competitions you have on the Zindi platform. So there are open competitions, meaning that those competitions are still accepting submissions. Some of them have closing dates, others are open till, whenever. Then there are competitions that are closed, meaning that you can no longer make submissions. Like I said earlier, you have prize, you can compete for money, for points, and for knowledge. Look at some of the challenges here. This is 17,000 USD. It starts in about a month or less than a month. Then this has 1 month to go. This is 10,000 USD, 3 months to go. So there's so many challenges you can get money from if you win. There are different difficulty levels for beginners, intermediate, and advanced. The one we're going to do today is for beginners. So if you've not done any machine learning, or if you've not done any hackathon for machine learning, and you're just getting started, yes. So what we're trying today is good for you. But something to take note of is that you need to be familiar with machine learning. If you don't know machine learning well, you may not understand what I'll be explaining. So I do hope that you've at least had some experience, some exposure to building machine learning models. So back to the platform, these are the different areas of machine learning. I won't think this is a skill, although it's stated skills here, but these are like different machine learning areas. So if you're more interested in classification, you just check classification and then you see challenges on classification. Then you have different topics. Like I said earlier, Zindi's challenges is really focused on solving real life challenges. So these are the different areas, where they have challenges. And if you're particularly interested in maybe a specific topic, you can just check on that and you see challenges around that. The one we'll be doing today is on financial inclusion. So it's more around finance. Then helping. So, usually for each competition, they sometimes are focused on helping or getting solutions for a particular country. I'll show you an example. Like if you look at this NASA Harvest Field Boundary Detection Challenge, it's really to help, drive solutions for farmers in Rwanda. And something you should note is that for these competitions, usually only those from Rwanda can apply. So I'm a Nigerian. I've indicated that I am from Nigeria. I will most likely not be able to participate in this. But don't worry about it. There are many other competitions that are not national specific, so any nationality can apply, right? So, but some of these challenges are specific to people from certain countries. Like here, this is for South Africa, and usually they will take submissions only from South Africans. So these are the challenges we have on the compete tab. Going on to the learn, here you find a lot of articles and you also even find articles from past winners or previous challenges. So in your own spare time, you can explore this further. There's a lot to learn on here. This talk usually I think it's for people to address, or what I've seen here is that it's used more to address problems with the challenges. So if somebody has some issue on here, like you can see this was posted 12 hours ago, they'll put it here. So that's what this is for. Then you have the community, which basically lists like all the users on the platform here. Then you have the job, which is listed by their rank. So you can see that the highest ranking person here is Assassin. Hope I got that right. And then there's a Nigerian here, Ola, then there's Mika D, and so on and so forth. So but I think this represents people that have been ranked on the platform. I think I should also be there somewhere. Then there's also the job platform. I haven't used this, but you can also use the Zindi platform to they have a job board, so you can make use of that and apply to jobs that you're interested in. Okay, so now let's go back to the compete part of things, because this is what we'll be focusing on. The challenge we'll be working on today is the financial inclusion challenge. I believe it's one of the most popular challenges on the Zindi platform, and so we're just going to be walking ourselves through that. So what I'm going to do is just type in financial inclusion here. Oh no, I didn't spell that right. Okay, financial inclusion. Okay, as you type, you see that the competition will come up. So you can see this is what we're going to be working on, and this is for knowledge. It's still active. 4,150 people enrolled. Active participants is 1,267. This is not country specific, so anyone on the platform can apply. So let's click on financial inclusion in Africa and get started. So once you click on financial inclusion in Africa, you'll be led into this page. And this is basically describing what the challenge is about. So you have the info, you have the data, you have discussions, leaderboard, team, and submissions. So for description, it's basically just prescribing what the challenge is about. So the challenge really is to create a machine learning model to predict which individuals are most likely to have or use a bank account. The models and solutions developed can then provide an indication of the state of financial inclusion in Kenya, Rwanda, Tanzania, and Uganda. Although this has been named financial inclusion in Africa, was basically for East African countries. We're all the same, this is a learning experience for us to know how to, participate in hackathons. So there's also an evaluation criteria. What I'm more used to is accuracy scores, but for this, they're using mean absolute error, so that the error rate of your model. Right. So as we progress, I'll show you how you can do that. Then, like I said, this competition is not for money. You're not going to win any money for this. You just most likely get some points for this, or I think it's actually knowledge, but for this particular challenge, you get some points. Then the timeline is not closing. This challenge started 3 years ago, and it still hasn't closed. So I don't know when it's going to close. But if you're willing, you can participate in the hackathon. There's some videos to guide you through your first challenge, your first submission. There are also some rules to how many times you can submit in a day, and so on and so forth. So in your spare time, you can spend more time going through all of that. So that's that for info. Then the next is the data. So this is like the data file, the file you're going to test and train, and all of that. So this is information about the data. If you go further down, you see the files. I'm more familiar with having one data set and then splitting that into a training data set and a test data set. But what I've discovered with Zindi is that there's a different file for training, there's a different file for testing. So that's what you also see here as well. To download, you just use the download link here. Really, I've already done this. I'm not going to spend time downloading it, right? But if we're going to do this, you just click the download button, you download right on your on your system. Then you have the variable definition CSV just to describe the columns you have, though same thing as the features in your data set. Then you have the sample submission. So this is just to show you how the submission you're going to make in they should look like. Right. So you're going to make sample submissions on Zindi, and this will guide you into what this should look like. Then you have the starter notebook. So this startup notebook was what helped me get started into making my first submission. So basically it has, like a guide, the codes that you can use, to make your first submission. But don't depend too much on this because you definitely would have to keep improving. So this starter notebook helped me, make my first submission, but I definitely had to, keep improving my machine learning model so that I could reduce my error rate. Okay, so that's something to note there as well. So that's that for data. We're going on to discussions. It's basically discussions and conversations around the challenge. There's a lot to learn from here. So people share the challenges they have. I think some people also share some of the solutions, but I don't think I got that from here. So, but in your own time, you can spend some time doing that. Then also the leaderboard. So that's the leaderboard for this challenge. This is my own this is my own ranking asset now. So I'm ranked 440. But at the time when I started, my first submission, I think I ranked 100 and, sorry, not 100. I ranked 419, thereabouts, if I remember the numbers now. But what to note is that more people are making submissions, and usually there'll be people whose error rates are much lower than, not much lower, are lower than yours. So that means that they'll be ranked, well ahead of you. And that will mean that, if someone's error rate is lower than yours and it's made the submission today, you no longer be at the rank where you were, you no longer be at the rank where you were today. You would, go further down the leaderboard. So if you're at 440, like for me, I'm at 440 today. But months ago, maybe about a month ago, I was 419. Right. Tomorrow I might be 450 or 445. So it depends on the number of submissions and the submissions that have, much lower error rates. So if you look at the first person here, this person submitted 3 years ago. You can see the number of submissions he made, 148, right? That's some great there. He had to submit, so he improved his model 148 times. And you can see it's right here on the leaderboard. More other people made more submissions. This person made 239. So I don't think there's any limit to the number of submissions you can make. There's no limit. So you can keep making submissions and you keep updating, based on what you submit. So you can see my own error score here was, or is right now 11.01. The first person is 10.5. You might think that that's a very small difference, but there are a lot of values between 10.5 and 11.01. So, well, what I would keep doing is keep trying to improve my model. You can reach out to any of these people here, but I don't know how quick they are to respond. So, but it's still something worth trying. All right, so that's that for the leaderboard. Then for the team, I don't have any team. I'm not a part of any team, but if I were a part of a team, that will show up here. Then these are the submissions I've made till date. This was the first submission. I think I did this 1st of January. And yes, my error rate was 11.06, and I improved again. I got 11.04. What did I even improve? I think I imputed more parameters. Then to get this 11.01, I think I used a different, I'll show you what I used, but I did improve something else there, and then I got this error rate. So yes, and then the last on the things to show is the submit. So this is how you submit. Once your submission file is ready, you just upload it, submit it here, and then immediately you'll be shown what your rank would be or what your rank is. So that's that for this. So now let's quickly go back to this place. Where is it again? Okay, sorry. I don't think I should have gone back, but financial inclusion. Let me just go to inclusion. Yeah, great. So, yeah, I haven't shown you all of that. So you understand what we're trying to do now. We're trying to predict whether individuals are have a bank account or not across these 4 countries. Right. So now let's go to the Google Colab sheet where we have all the codes that I use for this challenge. Don't worry, I'm going to include the PDF file so you can see you can have a copy of it. Feel free to use the code. And if you have, ways that I can improve my model, I've not focused on it now, but if you do have ways to improve my model and reduce error rates, please let me know. Right, I'll be willing to hear from you. Okay, so now let's go to our Google Colab sheet. So you can use Jupyter Notebooks, but for this, I've just used Google Colab. The first thing to do when you have the Google Colab is, to upload your file. So apart from, having your, sorry about that. So apart from having your files on here, you can, put in the the name of the sheet, all of those things, but I'm not going to worry so much about that. It's not Power BI. So the first thing I would put in here is to put in my data set. So remember the data set that we downloaded from here, from data, the train CSV and the test CSV. So I'm going to download that. I've already downloaded it, so I'm just showing you that this is where I'm going to upload it. So this is the upload icon here. So when I click on that, this is my test and train. I just, highlight those and then open. But I won't do that because I've already done it. So I'm just showing you how I'm doing this. For third submission CSV, I'm going to let you know how that comes in. So, but don't be worried about that for now. So to start my financial inclusion machine learning model, so I just did like a brief what's the word now, introduction to say, oh, this is what I'm trying to do with this project. But let's get down into the nitty-gritty of all of this. So the first thing I did was to import the necessary libraries. So my pandas, numpy, cbon, matplotlib. Usually I will just import libraries as I go on. I don't know all the libraries I would need, so I would just, import them as I go. So this is for data frame and plotting, cbon and matplotlib. Then for machine learning, we're definitely going to train and test our data set. So we have to import this. We also need accuracy score. With accuracy score, we're going to get our error rate. So this is also important as well. Then there's the import warnings as well. And yeah, that's like the first modules or libraries rather that I've imported right here. So now the first thing I'm going to do is now to import my test and train data sets. So I'm going to do my pd.vcsv. This is my train CSV that we uploaded here. This is the test CSV as well. I've just named my train CSV as train, test CSV as test. Right. After that, I just want to know, okay, how many rows, how many columns are in my data set, both for the training and the test data set. So using this train.shape, I can tell that there are 23,000 rows and 13 columns, and there are 10,000 rows, more than 10,000 rows and 12 columns in the test data set. Usually, the number of columns across the test and the train data set should be the same. But what Zindi has done is that they've excluded the target column. So from the test data set. So that's why there's a difference. So exploring the train data set further, I just want to see what it looks like, So I'll just explore what my data set looks like. I said to do a trained on sample just to see 4 samples of my data set. You can also use a train.head. That will give you the first 4 rows of your data set. You can use a train.tail. That will give you the last 4 rows of your data set. Remember, you can also change the numbers, right? So in my mind, you're familiar with all of this I'm saying. If you're not familiar with it, you might need to do, some maybe watching videos around machine learning. But I imagine that you already know about machine learning models and yeah. Okay, so now to get a bit more information about my training data set, I thought I explore, a bit more information about it. And this train.info that I've used here would tell me about the data type and how many rows I have across each, how many non-null, that's true, how many non-empty rows I have across each column. And basically I use this to just check whether there are if I use this to just check if the number of rows per the column matches with the total number of entries in the data set. So, but you can see that everything, there's no empty cell. Everything seems to, match properly. So, and then these are different data types. Object that shows you that the column there contains text data. Int 464 tells you that it's an integer. All right. So that's that for that there. So I just want to also check if, just in case there's any null. So I use my trainers null to check no null in my data set. So now I can start to explore the columns further. So I focus now on the target column. So my target column is the bank account column that tells me whether someone has a bank account or not. So I'm just exploring with this plot, this graph to see how many people say yes. Sorry, how many people actually have bank accounts and how many people have no bank accounts. So you can see that there's a lot of difference between those that have bank accounts and those that don't have bank accounts. Okay, so now the next thing is the data pre-processing. So it's like processing our data just before we impute it into our machine learning model. So the first thing I want to do is to label and code. So because machine learning models work better with numerical data, they don't work so well with categorical data. So we'll have to convert our text into a format that our model can read, right? Which is basically numbers. So that's why I've imported this label encoder. Then this scaler is really just to scale the features of my data set. So the first thing I label encode is the bank account column. So because it contains text, yes and no, I want to label encode it so that, my yes can be maybe 0 or 1 and my no can be maybe 1 or 0. So whichever one, it would label and encode it for me. Okay, so that's what I did here with label encoding the bank account. Then I also try to separate what's the word now? My train data. I've also done such a way that I've dropped the bank account ID. So if you're very familiar with train test split, you know that there is the training part and then there's the testing part. There's the X train and there's the Y train. So the X train is basically all the features of your data, or the selected features of your data, and then the Y train is the target feature. So remember that the target feature for our data in our data set is the bank account, right? And this X train contains all the other features that will determine whether somebody has a bank account or not. So this is just what I've done here. So just to see the sample of my X-ray to see, okay, if this bank account have actually been dropped, this is basically what I did with the sample here. And you can see that bank account no longer exists in my X-train. Okay, so that's that. So now I need to also be able to convert all the other text data, that is all the categorical data, into numbers. So the first one I did was just for the bank account. I need to do it for the other text data. So like you can see here, country is the text data, unique ID. We're not going to use that. Location type, it says text, cell phone access, text, gender of respondent is text, and the same with the other one. So we need to convert all of this, into numerical data. So this, I think I got it from the starter. Is it the starter node now? Under data here. Where is it now? Yeah, the starter notebook. So I got this function from there, but basically just helps you to convert all your text data into numbers, right? So I created a function called processor, and then it takes in the data that you want and does all the conversion for you. So I've also converted the integer columns to float. This is basically to just improve precision. That's basically what I did this for. Then I did label encoding. So all my text data has now been converted into numerical data. I dropped the unique ID column because it does not have any effect on whether someone has a bank account or not. It's basically just an ID. It's like a serial number. It has nothing to do, does not impact whether someone has a bank account or not. So I've also dropped the unique ID. So it's just some sort of feature engineering there. And then I've asked this function to also scale my data and then return the data. So with this function, I'm now going to transform the categorical data, including even the integer column. So I'm going to convert the integer columns as stated in these functions into float, and I'm going to convert all the categorical data into numbers. So we have that. So that's what this xtrain is. I put in my xtrain in this function. So I have now named the processed xtrain as ptrain. So P that starts standing for processed. So my xtrain data has gone through all of this and is now called ptrain. My test data, which is this one that we brought in from here, has also now been processed and is now called ptest. Okay. So the next thing I do now is to use a machine learning algorithm. So let me just introduce you to what's called the Halfin Grid Search CV. So because there are many machine learning models I can employ to determine which one will give me the best accuracy score, the best or the lowest error rate. But I don't want to do that manually. So I'm going to use the Halfin Grid Search CV to help me determine the best combinations of parameters that I can use to get, or rather the best optimal parameter combinations that I can use to identify the model that will perform best. I don't know if you get me there. So Halfin Grid Search CV, you can do a bit more research on that. Will help me find the optimal combination of parameters that will give me a machine learning model that will perform the best. Okay, so aside the Halfin Grid Search CV, there's also the Grid Search CV, and they basically do the same, almost the same thing, but they just have different approaches, right? And one thing you should note is that the Halfin Grid Search CV is way faster. Like if I can tell you, it's way faster than the Grid Search CV. So they do similar things, but have different approaches. Halfin Grid Search CV is about 11 times faster than the Grid Search CV. When I did the Grid Search CV, it took me more than 2 hours and I couldn't even wait. So I then did a bit of research and discovered the Halfin Grid Search CV, and I was able to run, I think what I was running ran for about 15 minutes, right? So it didn't take so much time. So that's the point of this Halfin Grid Search CV. You'll see how I use it further down. So then I've now decided to split my training data. So remember there's a train data. That's what we imported here. There's a test data. But then I've decided to split my train data into a training. So I will split my train data in such a way that some part of it will be for testing and then the rest will be for training, right? You still have to test your data. That's how you know that, you can identify or detect the best performing model. So I've decided to test only 10% of my training data and train 90% of my training data. So you can see that here, my X train, all of that. So I put in random state so that the result don't keep changing every time. So this is how I did my split train test. Yes. And then my test size was 0.1. Then these are all the libraries I want to try. So there are many more libraries, but these are the libraries I want to try. And then I want my Halfin Grid Search CV to tell me which of these will give me the highest, the best performance, and then which parameters to use to get the best performance. So these are all the libraries, and then these are the parameters. So you need to specify the parameters you want for each model, right? So C for SVM, that's a support vector machine. These are the parameters. So this is C. I asked it to test across 0.1, 1, 10, and 100. So you can make it more, you can make it less, but the more you have, the more time it will take to run, right? So you should note that. Then you have gamma. So it's going to, what Halfin Grid Search CV is going to do, will test, for when C equals to 0.1, when gamma equals to 1, when kernel equals to RBF, and then you will test all the possible cases for this. So you can see that this really works, really good, rather than having to test manually, test when this is that. So Halfin Grid CV will test all the cases for you and then tell you the best performing model. So I did that here too. I found some more parameters I added. Yes, so don't be scared if you've not tried this before. I'll leave the PDF file in the description box so you can, go through it in your own time as well. But I'll be willing to hear from you. I'll also be willing to see you I would like to see you rather on the leaderboard. So do tell me when you try, this hackathon. Okay, so that's it for the parameters. So you need to state the parameters. So after that has been stated, I can then now tell my, do so like a function and let my helping grid search CV tell me the best parameters, to use, or rather the best model and with the best parameters. So you can see now these are all the what's the word now? These are the models that I tried, right? And these are the scores. So these are the accuracy scores. I can see that the highest here is 0.887. So that it gives you an accuracy score of 88.76. And then it's telling you now that these are the parameters you would use to get a good accuracy, right? So you can see this does really good work for you. So I'm going to go with the XGB classifier. And yes, after doing that, I imported my confusion matrix and accuracy score. Okay, I've already done accuracy score. I shouldn't have imported it again, but it's okay. Confusion matrix, you don't have to do this for submission, but I just wanted to visualize that. So that's why I imported confusion matrix, but you don't need it to submit. So now I'm deciding on my XGB model, and these are the parameters I'm going to be using based on what I got off here. Okay, so I'm going to fit in my X train and Y train, then my predict. I'm also going to predict using my X test. So that's that. So remember, this X test is part of our training data. It's 10% of our training data. It is not the actual test data set, which is this test for CSB. It is just 10% of my training data. Okay, so to get my error rate, I'm just going to do 1 minus accuracy score, and I have that here. So you can see that my error rate is 10.79 something something, right? So now, okay, so 10.79. So I do my confusion matrix. Remember, it's not part of the major thing. It's just because I wanted to see it visually. So now, we're now going to use the best performing model, that's the XGB model, to predict based on the actual test data. But remember, this P test was processed test data from here. Remember, this test one, right? This test one, this test, the actual testing data set. So I processed it and made it P test. So now I'm now going to test the testing data set with my XGB model. The test I did here was part of the training data, was just a part of my training data. And I needed to test it just to see what the error rate will be. So, but the error rate I get here will be different from the error rate I get from these P tests, right? Because it obviously contains different data sets. So this test, X test, I'm just trying to clarify that this X test is a part of the training data set. And then this P test is actually the testing data set we're supposed to use with our, best performing model. So after that has been done, so I named that test bank account. I read in our test CSV. I think I've already done that at the beginning, but I read it again. So this time I named it test underscore data. And if you were to go to the starter notebook, you see that this is the format you need for your submission. So I've just basically imputed that format here. So we're creating a data frame with this column, unique ID. Then our test data is basically just a unique ID and then the country. And then we have another column known as bank account, and it's going to now include what was predicted out of our actual testing data. So this is what we have. This is what your submission should be looking like, right? So this is what I have here. And then I then converted my submission into CSV. So that CSV will then be what I'll upload on Zindi. So once you do this, this third submission CSV will automatically appear here after like a few seconds or so. So this is how, to do or participate in a hackathon or to actually do the financial inclusion challenge on Zindi. So I'm just going to go back to the platform, the Zindi platform. And yes, let's now go back to submit. So, let me even go back. So let me come back here and then just download. Okay. So you need to download that there. It's downloaded already. So now we go back to the Zindi platform and then we can try to make our submission. So note that this submission has been done. It was actually my third submission, but I'm just going to show you how to do it. Okay. So let's click on submit now. So let's choose the file. I think it should be my downloads. Okay, third submission too. So you can see it there. You can make a comment, but I don't really make comments. I just submit. So let's submit it. Scoring. Can you see it scoring? I think I get the same score. Nothing has changed. So you can see. And once this has been scored, you can see yourself on the leaderboard. So I'll come back and see myself. I still remain the same. So nothing has really changed regarding ranking. But like I said, as more people enroll and as they get lower error rates, it means that other people will go further down the leaderboard. But if you keep improving on your machine learning model and you get a lower error rate, obviously you will go up the leaderboard. So I hope you've been able to learn, from this video on starting or participating in a challenge on Zindi or Zindi rather. I do look forward to participating in more challenges, and we never know, we will win some $5,000 with hackathon. But I look forward to participating more. It's a really good experience, and I'm very happy to have been able to share this with you. So, like I said earlier, please, if you're going to try, please let me know. I'd like to see you on the leaderboard. It would really make me happy, and I encourage you to participate. So don't think it's hard. I've shown you how. I'm also going to share the PDF file with you. So if you have any problems, let me know. I don't assume myself as an expert, but I'll just show you what I have done. So we can work on it together. If you have any questions, do let me know. My email address rather is on the description. I'll also leave in my LinkedIn profile so you can reach out to me there. So with this, I'll say very big thank you for watching my video. I do thank you so much for all the likes, for all the comments, all the subscription. I very much appreciate it. Thank you so much for supporting my journey as a data scientist. Thank you for your time. Thank you again for watching. Do have a very lovely evening. Bye bye.